Welcome everyone. So this is our 72nd live stream geometry. We have two people here with us from Greece and Turkey. And today I'm going to take problems from the Canadian math journal called Crux Mathematicorum. So it's been around for quite a while. It's had some really good problems for both like at the undergraduate and high school level. I'm not sure why I've never taken problems from it yet, but the problems are now free online ever since 2019. So I see we just have another person join. If you guys want to join us in the future, feel free to email me at mgreenb801@gmail.com. So we meet every Sunday at 8 a.m. US Central Time if you'd like to join us. So with that, I'm going to share my screen. So hold on just a second. All right, so here's the first problem, and this one I believe was proposed by Buratino. So we will see how hard it is, or if it's not that hard. So we have a triangle ABC, and the in circle is tangent at D, E, and F. So let's draw the in circle. Draw the points of tangency, D, E, and F. And then we draw perpendiculars to BC at B and C. And we see where they meet EF. So I can go close this. We let them meet at M and N. So this is M and this is N. And then DM and DN intersect the circle at P and Q. Whoops. And then BP or BQ cuts CP at R. So this is P, this is Q, and BQ intersects CP at R. And we want to show that DR bisects MN. So the nice little configuration. That's R. And now I'm going to hide stuff. 1, 2, 3. And that is the problem. So maybe projective geometry might be helpful. Let me draw the ray DR. And let me draw in the segment.
And also draw the midpoint of BC.
Yeah, sure.
And intersect A median with EF.
Okay. Okay, so Constantinitis or KR has seen this before, it looks like. So yeah, if you know the solution, don't give it away. But
I also draw DJ segment DJ.
BJ?
DJ.
Oh, DJ. It looks perpendicular. Yeah, well, actually, yeah, we know it's.
Yeah, it's well known.
Yeah. All right. So I see Stefan just joined, so thanks for joining. So yeah, these look like they do those actually concur? I think that's a coincidence. Yeah, no, those three don't actually concur. You remember the solution. Okay, it'll be interesting to see if we find the same one that you saw before. Yeah. So dr, yeah, I want E and G to be a little farther apart. Yeah, I want E and G to be far apart, but I also don't want to make it look like these three concur. So I'm trying to do both of those at once. I think that's good enough. So this AFE is isosceles, so angle MFB is equal to angle NEC. So yeah. Maybe I'll just draw the center of the circle. Call it I. Yeah, I wonder if we can, what if I drew the parallel through D to EF?
I was thinking the exactly same thing.
So if it meets the circle at K, then we would have we want to show PQK. Yeah, but then I would need to draw this point too, which maybe
looks like PQ is parallel to BC.
I'm not. You might be right. I didn't think it was when I saw this earlier, but maybe you're right.
And also this configuration looks very familiar.
Oh, really?
Yeah.
Oh,
I think we did some problems similar to this. I think it had something to do with the intersection of CM and BN.
CM and BN. Okay.
Yeah. I think that intersection lies on DI.
Ah, interesting. So this point L might be useful.
And also, if we prove that PQ is parallel to BC, that looks very useful.
Okay. Yeah, let's see if we can prove that. So yeah, that does look familiar, like with PQ being parallel to BC. So that's like the same as this angle being equal to this angle, right? Which is the same as these triangles being similar. And is that obvious? I wonder if MFDB is cyclic, because that would no. So yeah, we want to show these are similar. So that's the same as saying that dB over dC is MB over NC, or which would be dm over dn, which would be mj over jn.
I think I have a point which would probably lead to proving this.
Okay.
Draw the perpendicular through D to EF.
The perpendicular through D to EF?
Yes.
Okay.
Then there is a useful thing about that point in this case. That is that FO over OE is equal to BD over DC.
Oh, I've seen that. Okay.
And then probably also holds that MO over ON is equal to BD over DC. I think that is something that I have proved in some session earlier when we did some problem with isogonal conjugates.
Okay. And so that would prove that PQ is parallel to BC. Oh, this might come from the JBMO. Is it the same problem as the JBMO 2015, or is it like that helps, that's related to it? Oh, it's really related. Okay. All right. Okay. So yeah, FO over OE is BD over DC. That's kind of a well-known. So yeah, that's part of the Sharkey double configuration. And then we want to show MO over OF is NO over OE. And for that,
I think that I made a mistake. I just checked OM over ON is not equal to that, but it is true that OF over OE
is BD over DC.
Yes. But nevertheless, it still looks like a useful point since we have two more cyclic quadrilaterals at this point, and we have some ratios.
Yeah, I think there's a good chance that that helps with that. Well, actually, I think that does solve it. That does prove it because angle PDB is angle MDB, which is angle MOB, which is angle FOB, right? But triangle FOB is similar to triangle EOC because basically
that is basically well known. Yeah.
Yeah.
I see what you mean.
Yeah. So we know now that PQ is parallel to BC. Interesting. Okay, so PQ is parallel to BC. We want to show DR bisects MN. So if we project onto the circle, we would have PQ, K, and then we would need one more point. I feel like we're close. Thinking just projective geometry. Maybe we could let dr intersect PQ and do something with that. Let me try something. Yeah, I was wondering, I don't think there's anything special about this point. Hmm. I wonder, let me try one other thing. I wonder if this is the foot of the altitude from A. No. Yeah, so I guess what we could do, we could let G prime be the midpoint of MN, and then we want to show G prime BC and DPQ are perspective. I don't know how much that helps. Actually, that's actually kind of interesting. So if we let G prime be the midpoint of MN, we want to show that G prime BC and DPQ are perspective. But PQ and BC meet at the point at infinity. So what would that mean? So,
Oh, I think I solved the problem.
okay.
So let me just explain what everything that leads to the end of solution. So we will use that PQ is parallel, and we will use it in this way. Let name the midpoint of PQ, and also you can delete the point L.
Okay. All right. So let me clean up a couple things. So I'll delete that. Do I need you still want this segment?
Yes, that is I think useful.
Okay. Whoops. There we go.
And then we can use that PQ is parallel to BC and see that L, R, and H are collinear.
Okay. Do you need point K?
I don't know what that point is, and I doubt I need it.
Okay. Okay. So we can show L, R, and H are collinear.
That is a thing I used multiple times in this session. It is you can prove that by Chavez theorem, and you can do it by just two similar triangles. I think there are multiple ways, but
because L is the midpoint of PQ and H is the midpoint of BC. Yeah, it's obvious. It's just homophoty because PRQ is homothetic to BRC. Yeah.
Basically yes.
Yeah.
You may define the point G as the midpoint of MN,
Okay.
and then we will prove that those three are collinear.
Okay.
So join HG.
Okay.
HG. Then we have that HG is the midline in the trapezoid BCMN.
Yes.
So that is that is parallel. I mean, HG is perpendicular to BC. That is what I meant.
Yeah.
And we want to show that D, R, and G are collinear by using some ratios. So we want to prove that DL over HG is equal to LR or RH.
Okay. All right.
Then LR or RH is the same thing as PQ over BC.
Okay.
Then we have a pretty nice ratios to prove. So in the end, it will be PQ over BC is equal to DL over HG.
Yes.
Then we will prove actually that PDQ is similar to BGC. And after that, we are done because the ratios. So it remains to prove that. We can see that both of those triangles are isosceles.
Yes.
That is pretty obvious. So we basically need to prove that angle PDQ is equal to BGC.
Yes.
Now I will just kind of state like theorem, which I knew from this configuration before. And that is that BOGC is cyclic.
Okay, BOGC is cyclic. I did not know that fact.
I think that is like some Korean problem.
Oh, really?
It can be found on Osman and Al's channel, a video about that. The whole problem is basically to prove that.
Yeah.
And it can be done in, I think, very easily with projected geometry. Like you extend EF to meet BC and use just, I think, one or two facts about harmonic bundles, and then you will have powerful point.
Okay. So yeah, seems like KR has seen this before too. Yeah. Okay. So you extend EF to meet BC and you use harmonics and a power point, and then you can show BOGC is cyclic.
Yes.
Okay.
Then we will do an angle trace to prove that BOC is the same angle as PDQ. Basically, this is not hard since we already have some cyclic quadrilaterals with this point O. For example, angle MOB is equal to MDB.
Oh yeah, because yeah. Okay. And then that proves it. Interesting. Yeah. I like it. There's yeah, the solution has a good amount of stuff involved. So all right. So I will start writing it So let G be the midpoint of MN. Then, so triangle FOB is similar to, or let O be the perpendicular from D to EF. And then we have basically triangle FOB is similar to EOC. So that's well known. Well known. See video on the Sharky Devil configuration. And then that
Also, in the end, I didn't use the point J, so you can delete it.
Okay. Yeah, so yeah, we didn't need, yeah, we just let L, let's see, okay, so I'm gonna hide this. So yeah, we don't need J. And looks like Shriyansh is joining us. Okay, so yeah, FOB, and then we have MODB is cyclic. So MODB and NODC are cyclic. NODC are cyclic to right angles. And so yeah, thanks for joining, Shriyansh. And so now we can do the angle chase. So angle MDB, I'll just say angle PDB equals angle MDB equals angle MOB, which is angle FOB, which is angle EOC, which is angle NOC, which is angle NBC, which is angle QDC. Maybe I made that longer than it had to be, but let's see how this turns out. So that implies arc PB is arc PQ, which means PQ is parallel to BC. So DQ, and that implies that PQ is parallel to BC. And then let L be the midpoint of PQ. PQ, so I, L, and B are collinear. And okay, so we want to show that LD over LR is RH over HG. Okay, hold on just 1 second. So now I'm trying to remember. So LR over RH is PQ over BC. Yeah, so we want to show BG, triangle BGC is similar to PDQ. Okay, so, and that's, so I'll say, so BOGC is cyclic. So I'll just say well-known Korean problem can be solved by letting EF intersect BC and using harmonics. right.
You can write that it is Korea 2017, day 1, problem 3.
Korea 2007.
2017.
Day 1, problem 3.
Yes.
Wow. So they must have thought it was hard. And then, so angle BGC equals angle BOC. BOC, which is 180 minus BOM minus NOC. That's 180 minus MDB minus MDC. And that's angle PDQ. Then those are both isosceles. So yeah, let me break this up. So PDQ is similar to BGC since both are isosceles. From there, we have LR over RH is PQ over BC. BC, which is equal to LD over GH. Over GH. Whoops. That means that DR and G are collinear. That means that DR bisects MN. Oops. Very nice. All right, so I will move on to the next one. So KR, was that the solution you saw before?
No, but you can instead consider the intersection of DR and MN and apply several ratios lemma and use some trigonometry to conclude that G is the midpoint.
Okay.
Okay, but this approach is more instructive and more intuitive, I think.
Interesting. Very interesting. I'll have to check out that other solution that you mentioned, but yeah, I like this one a lot.
You can write it in Discord.
Yeah, of course.
All right.
All right.
All right, so here's the next problem. So ABC is a triangle with circumcircle O, orthocenter H. Let's see, we have BC and AC. So I think we want C to be the point at the top, the way they make this problem. Okay, so let's draw the circumcircle. Do we use point O in the problem? I don't think so. I'm not even going to draw O because I don't think it gets used. Okay. So AD is perpendicular to BC. So this is D, this is E. This is H. And F and G are the fourth vertices of CADF and CBEG. Okay, so they're kind of, yeah, let's see if we can make this look a little better. So CA. Yeah, so I'm going to do it like this. Yeah, okay, I might want to shrink this triangle a little bit so that we can see. I'm going to reflect A across F and B across G. All right. There we go. So, okay, this should be F. And this should be G. I'm going to hide these two. Let me draw the parallelograms. So CABF is a parallelogram and CBEG is a parallelogram. X is the midpoint of FG. Y is the point where FC intersects the circle again. Okay, so we do need to draw the circle. Okay. Then we want to show ABHY is a parallelogram. This is a cool problem.
That intersection is not as important. We just need to prove that it goes through the circumcenter.
Okay. Yeah. Okay, that's a good point. So let me draw the center. Yeah, we need to show that it passes through yeah, the circumcenter. Yeah, let me call O. All right. So yeah, I'm going to hide this for now. We just, yeah, we want to show X, C, and O are collinear. One sec, guys. I'll be right back. All right, I am back. Okay, yeah, so we want to show X, C, and O are collinear. We know angle OCB and OCA, not XCB and XCA. Are these right angles right here? Is that obvious? Yeah, that must be obvious. Yeah, CAD and CDF are congruent. So yeah, they have to be right angles, yeah. So we really just have to calculate angle XCF. Okay, so yeah, we have, this is congruent to this is congruent to this. So do we have any, so CF over CG, yeah, so these two are similar. So yeah, CGF and CED it's like their sides are in the same ratio, but their angles are 180 minus each other. Is XC perpendicular to FC, GC? Is X, oh. No, this isn't a right angle right here. This is going to be 180 minus angle C. Sometimes I call these like pseudo similar triangles. Like if you look at triangle CED and CFG, these two sides are in the same ratio, but instead of the angle being the same, it's 180 minus it. Yeah. Is BHC, I'm sorry, is BHA similar? I wonder if triangle BHA is similar to triangle CFG. So yeah, what is this angle right here? I always measure it the wrong way. I knew it would be the wrong way. Okay, I don't think they are. Yeah. Reflect the orthocenter over AC and AB. Okay. So yeah, that's going to lie on the circle. And I can call it something better.
I think I have done a problem extremely similar to this before, and it wasn't really hard.
Okay.
It was a bit more general than this, but I have proved the necessary condition to make it exactly the same as that problem.
Okay.
So, we take points F and G such that CF is perpendicular to BC and the other is also perpendicular. But there is also another condition that BC times CF is equal to AC times CG.
Okay.
And if that condition holds, then it is then you need to prove exactly the same thing as we need to prove. So I'll just try to remember how I solved that problem before.
How you did that one? Yeah,
I think I did trigonometry, but not much. Like
only a little bit.
Yes.
Okay, so yeah, BC times CF is AC times CG, and these are perpendicular. Then X, C, and O would be collinear. That's interesting.
I think that triangle CGF, we have complete characterization. We have the angle and two of its sides.
Are CFB and CAG similar? Let's see. If they were.
Oh yeah, I remember the solution.
Okay.
So we take a point x prime such that CO and x prime are collinear.
Okay.
Then we wish to prove that sine of GCX prime over sine of FCX prime is GC over CF. That is like a well-known thing when you have the midpoint and trigonometry.
Okay. Triangle. Can't we just calculate? Yeah, I think Shriyansh might be like saying the same thing. So, okay, so we want to show that x prime is the midpoint of FG, and that is the same as saying that GC over sine GCX prime is CF over sine FCX prime. But yeah, how do we get this? Let's see, this angle. So this angle is basically 90 minus ACO, and this angle is 90 minus BCO, and so that's how we would get it, basically.
Yeah.
Okay. Yeah, it feels like there has to be a way to do that without trig. I'm just thinking, because that I know that works. But yeah, I mean, trig makes it, I agree, trig makes it pretty obvious though. So maybe that's just okay. I wonder, let me just try something. If this doesn't work out, yeah, then I'll just use the trig solution. Oh wait, yeah, that's not gonna work. Okay. Yeah, I think, yeah, the solution's simple enough. So I'm just because P and Q aren't used in this, I'm gonna delete them for now. So let OC intersect FG at X prime. Right. Oh, sorry, it's a little hard to hear me. I'll check into my mic a little bit after this.
No, not you, Michael. I can hear you properly, but Shriyansh.
Oh, Shriyansh. Okay.
Because I noticed that he was speaking, but no one really noticed.
Okay. All right. So I think that's the only real point we need to define. And then, so first angle GCX prime. So angle GCE is angle CEB is 90. GCE is CEB. Similarly, angle FCB is 90. And so angle GCX prime is 90 minus angle ACO. And then similarly, angle FCX prime is 90 minus angle BCO. And so then we can take the ratio of the two sides. So if we take the ratio of the sides, then we have so sine of GCX prime over sine of FCX prime. Wait, is that right? Yeah. And I'll just add the angles because why not? And that would be equal to cosine of ACO over cosine of BCO. And then it's pretty easy to see that that should be like CE over CD, I'm guessing. Let me just think about that for a sec. So cosine of ACO, that's, sorry. Oh, a backslash sign. Let's see. I could try it. There we go. So cosine ACO, that's like, okay, so that's AC over 2 over R over OC. So to OC and then BC over 2 OC. And which is that's got to turn out to be because these two triangles are similar. So AC over BC. Okay, so I'll just write this out. So this is AC over BC, and then what triangle ADC is similar to triangle BEC. Actually, I think that's kind of obvious. So I'll just say AC over BC is CD over CE. And that is CF over CG. Because those triangles are similar. So because that's true, so yeah, I'll just write those similarities. So the triangle ABC, CAB is similar to triangle CBE. That basically means that FCD is similar to GCE. GCE. So then we got all these things, and this means that X prime is the midpoint of FG.
Sir, is my voice audible?
Oh, I can hear you now, or a little bit better.
Oh, so I think I found a synthetic solution.
A synthetic solution? Okay.
What you can do is extend GC, reflect G over C.
Okay.
And we can see that triangle CFG dash is congruent to triangle CAB.
It's congruent to triangle CAB.
Yeah, the original triangle.
Ah,
And because there are two midpoints, C is a midpoint and X dash is a midpoint, we can use the midpoint theorem to directly get angle X dash CG.
oh, that's pretty clever. Okay. So C is the midpoint of G prime, and so you define X prime the same way. Okay. Like you define X prime in the same way.
Yeah, X prime is the midpoint.
Okay, you define X prime as the midpoint. And so then those are parallel, and so then you can calculate this angle. And
Yeah,
from,
it's equal to angle CG dash F, and that can be directly calculated as CAB.
okay. Let's think about that. So yeah, okay, so that avoids having to use the trigonometry. That's just purely synthetic. Okay, so
G dash F is equal to angle A.
yeah, that makes sense. Okay, I'm gonna finish writing up this one, and then below it, I'm gonna write that idea. So this means so once we know that, so OC passes through Y. Well, that's kind of well known. Or I'll say, yeah. So if OC cuts the circle at Y prime, it's well known that AHBY prime is parallelogram. This, yeah, so this is a weird way of saying it, but Y prime equals Y. So ABHY is a parallelogram. All right, so I'm going to draw that point Y, just because, yeah, the solution feels a little weird without it. All right. I'll say alternatively, let G prime be the reflection of G over C. C. And then we have triangle FCG prime is congruent to CAB. So let me think about that. So so this angle is equal to angle C, and then this is equal to this. So yeah, okay. So I'll just say it's easy to show that let's see, G prime is congruent CAB. And that means that so that would imply that CX is parallel to FG prime. And that implies that X, C, and O are collinear biangle chase. All right, so yeah, I'll let the viewers figure that out. And then that implies that ABHY is a parallelogram. All right, so I'm going to move on to the next one. That's pretty, I like that idea. Purely synthetic. Sounds good to me. All right, so the next problem. So we have a triangle ABC, scalene, and H is the orthocenter. And then we draw the parallel to BC through the orthocenter. So yeah, let me just draw it this way. So it doesn't get too messy. All right, close this. And we draw the parallel to BC through H. And then this actually feels a little familiar. I can't, but yeah, we want to draw the perpendiculars to AC and AB. And yeah, so we label these 4 points. So this should be EF. And these should be U and B. So I'll make this U and B. And then we project A onto BU and CV. And we want to show that EF, X, and Y are cyclic. So that's BU, this is CV. Let's see, try to make these points look nice. So this is going to be X and that's going to be a Y. All right. So let's draw all those in, a Y, a X, a U, a V.
A also lies on that circle.
Interesting.
That is a very natural thing to consider, since we would have 2 perpendiculars, and it turns out that it is a circle with diameter on that intersection point.
Interesting.
But we need to prove that.
Yeah. Okay, so So we know AXT and we know AYXT is cyclic. We have to show that E and F lies on that. So yeah, how do we use that H as the orthocenter? Maybe it might help to draw the circumcircle. Then the reflection of H over BC is on the circumcircle. I'm not sure. So yeah. So I'll be right back. All right, I am back.
We need to prove just that D lies on the, that the circumcenter lies on line AD.
Oh, really? Let's draw it. So if O is the circumcenter. So once we show that, how does that solve it?
Then it is kind of obvious that it is cyclic, I think.
Oh.
Maybe like homotopy or something.
Okay.
Yeah, I think homotopy would do the thing.
I mean, I guess, yeah, you have to use that H and O are like isogonal conjugates, right? Somehow, or like.
It may be an angle chase, but homotopy can also do it like you take the antipode of A and okay, maybe it isn't like enough, but it is something that we should prove.
Okay. But it probably makes it probably easier. Yeah. A lot easier.
Yeah.
Okay. I feel like I've seen points U and V in a previous problem, but I forgot, yeah, what I did with it. Consider the feet from B and C. Okay. So I'll draw those in. Oh, okay. Okay. So yeah, another way we could do it is we could let the perpendiculars at E and F to AE and AF intersect at D prime. And then we want to show like V, D prime, and C are collinear. I kind of like that idea. Let AX intersect the circle at T, and similarly for AY. Okay. Let me shrink the diagram a little bit. So I'll call it T and U. Suffices to show that GC TC is parallel to XF. Well, we want to show XF is perpendicular to AC, right? So, oh no, I'm sorry, that we wanted to show that DF is perpendicular. So is that, so we want to show XF is parallel to TC. That's interesting. Okay. All right. Oh, let me, yeah, I'll name this S because I want this to be U. All right, see you next time. Thanks for joining us. All right. All right, let's see. So yeah, I mean, basically we want to show DF is parallel to AB, right? And DE is parallel to AU. So maybe it's like easier to define like a point B prime like this. I'm wondering. I kind of like that a little. Maybe that might be a little easier. Like, what if we take the perpendiculars at E and F, and we let them intersect at a point B prime, and then we let CB intersect EF at V prime, and then we want to show AV prime is parallel to DF. So that, I don't, yeah, let me think about that.
I just want to share one thing that I found. It looks like BV, CU, and AH concur.
Interesting. Okay.
Also, I will also have to go in like 5 or 6 minutes.
Okay. All right. Okay, so these three concur. So you said you qualified, it was I think you said you qualified for the JBMO, right?
Yes, that is true.
Do you know when the contest is?
The contest is on the problems we are going to do on the 30th of June.
Okay.
So in about 2 weeks, 2.5 weeks.
A couple weeks. Should be fun.
Yeah. I just hope I will do more than just geometry.
Geometry, yeah. So yeah, those three concur. Oops. I'm gonna hide some stuff. Looks like Serdar is rejoining. Hey Serdar, thanks for rejoining. All right. So yeah, that's an interesting observation that those concur. Yeah, let me draw back in AU and AV. So yeah, I kind of want to show that CD over CV is CF over CA. And CD over DV is BC over VU. So.
Oh, that is actually obvious. I know how to prove that.
Oh, really?
Yeah. We will have just a similar triangle. So CD over DV, that is equal to BC over VU.
Yes.
And CF over FA, that is equal to name the point, the feet of altitude from A.
From A. Okay.
Yes. Then CF over FA is equal to IH over HA.
Oh.
And then it is very easy to prove that BHC and VAU are similar.
BAU, what were the two again? Say it one more time.
BHC.
Okay. And VAU.
And those two are, and we have those are corresponding points. And yes.
Okay. All right. So I think we can get rid of point G in that solution, right? I think that
Yes,
solves it. Okay. So basically, yeah, I'm just going to delete these for now. Okay. Okay, so we have CD over DV is BC over V. Oh, whoops, I erased the foot of the altitude. That's my bad. Okay, I'm just gonna keep this. Let me just delete things one by one. Hide this and this. Okay, so these I should be able to delete. Okay. All right. Okay, so BC over VU, but then triangle BDC, no, sorry. Okay, BC over VU, and then I'm trying to remember, so triangle BHC is similar to VAU. So BC over VU is the same as HI over AH, and that is the same as AF over FC. Okay. So that solves it. Okay. So I'm going to write it up. So yeah, whenever you have to leave, Stefan, yeah, it's fine. But yeah, I appreciate all your help in the session today.
It is just on time since I will leave in a couple of minutes. So we solved this third problem. All
right, sounds good. So VD over DC. VD over DC is equal to VU over BC. BC. And that then triangle BHC is similar to ABU because both are parallel. So I'm going to write that. So BH is parallel to AV and CH is parallel to AU. So if you combine those, then basically triangle AVU is similar to HBC. And so once you have that, then you have V over BC is AH over AI.
You have a typo in this VD over DV in the first thing.
VD over DC. And yeah, I think this should be AH over HI. Let me see. So VD over DC is VU over BC, which is AH over HI, which is AF over FC. And then, so this means that AV is parallel to DF, which means that DF is perpendicular to AC. And then similarly, DE is perpendicular to AB. And then once we have that, then we know that, yeah, they're all cyclic because, so angle AED is angle AFD is angle AXD is angle AYD is equal to 90. And so that means that let me see just the order, AEYXDF is cyclic. Is cyclic. I don't even know if we define point B in the so yeah, I'll say let C U intersect B, let CB intersect BU at D. All right. Yeah, I think Shriyan tried to hop off. All right, so that is this problem.
I will also go now. Bye.
All right, take care. Have a good one. All right, so it's just me and you, Sardar, for now. So for this problem, we have, I think, let me see if there's a harder one. I think this one might have been a little easy. This one was
problem with circles, because every problem was about projections and 90 degrees.
This one? Or
is there a thing about circles?
This one looks kind of tricky. So
this looks awful.
it looks awful.
Yeah.
Let me.
Another problem.
Okay. So this one's kind of interesting. So we have a cyclic quadrilateral, and then let's see, A, B, C, D, and then X is a point on CD, and we project it onto AD, BC, AC, and BD. Okay, so X is any point here. Okay, right. AD, BC. And then AC and BD. So it's like, okay, so we take those projections. Okay, so first AD and BC. and then AC and BD. So yeah, that doesn't look so bad. It's just those four. So yeah, once I clean it up, I don't think it'll look too bad of a diagram. So just these two and these two. So the diagonals and these two sides. Yeah, I didn't need to make everything lines, but all right. Yeah, I kind of did just in case, but yeah, really, yeah, I didn't have to do any lines. So we have this. So XE and XF are perpendiculars. And if you draw the diagonals, so yeah, I'm gonna possibly rename them. We want to show the angle between EH and FG is constant. So E is onto AD, EF is BC, G, okay, so G and H are switched. So yeah, it's saying that the angle between EH and GF is constant. So let's draw that. So if we move X around, this angle is kind of always the same. I wonder if it like traces out a circle, although I don't think it does. Let's see. Oh, it looks like it moves on the line AB. Wait, so AI and B are collinear? That's interesting. Let me make this bigger. This diagram. So yeah, there's two interesting things. So yeah, AI and B are collinear. I don't see why that's true immediately. And then the angle they're saying is always the same. So I'm going to delete that for now. Obviously, these are cyclic right here. And yeah, we could draw a point right here too. So the intersection of the diagonals. All right. So yeah, we have three cyclic quads here. Let's see. Like maybe we could calculate, because BD and AC are fixed. So maybe we could calculate the angle. I'm sorry, go on.
Equals to angle DAJ, and it's easy to calculate from just angle chasing.
Oh, really? This angle's angle DAJ?
Can you check it
Yeah, so that would mean this is cyclic basically. Okay,
It's just the angle chasing.
okay,
I will write it in the chat.
okay. So yeah, this one was an easy one, I guess. Because, yeah, we could, yeah, figure out the angle that this makes with BB. Yeah, I think I kind of see the angle chase because the angle between EH and GF, that's the angle that EH, we can find the angle that EH makes with BB, and that's angle EHD, which is angle EXD. And then we can find the angle that FG makes with AC the same way. And yeah, because angle CXD is always constant. So yeah, it's not that hard of a problem.
Yeah, we can skip maybe without writing the solution.
Yeah, I'm just gonna copy what you wrote and put it as text. But yeah, this one is a little too easy, I guess. All right, so we could try this one. I forget, why didn't I do this one? Oh,